Good morning. So we are ready to start our next chapter. We're in chapter 5 now, ratios, rates, and proportions. So we're going to start today. Whoops, I'm sorry. We are going to start today with the definition of a ratio. So a ratio is a comparison. Make sure you're copying down in your notes as you're watching the video. A comparison of two quantities. A quantity is an amount or a number. Quantities using division. A comparison of two quantities using division. Ratios can be written in three different ways. The first way is with a colon. A colon is two dots that look like that. The second way is with a fraction bar. We all know what that is. And the third way is just simply writing the word two. All right, so if I have 3 cats and 4 dogs, I could write that using a colon. I could say the ratio of cats to dogs at my house is 3 to 4. Or I could say the ratio is 3 to 4. Or I could say the ratio is 3 to 4. So notice that when I used the colon, that's read as the word two. The fraction bar is read as the word two, and clearly the word two would be read as the word two. So all of those ratios are read 3 to 4. All right, so what's the difference between a ratio and a rate? Next definition, a rate is a ratio of two quantities so here comes the difference with different units. So an example of that would be 60 miles in 2 hours. So my first unit is miles, and my second unit is hours. So the two units within the same rate are going to be different. Another example of that would be 20 miles in 4 minutes. 20 miles in 4 minutes. So my different units here are miles and minutes. And unit rate, our last definition. So this is a simplified rate. A rate with a denominator of 1. So this is when you take your original rate and you reduce it to lowest terms. So when you have a unit rate, the number on the bottom has to be a 1. So if we go back up and look at the rates that I had up here, remember I had 60 miles in 2 hours. Well, if I copy that down here, 60 miles in 2 hours, now a unit rate has to have a 1 on the bottom, so that's going to have to be 1 hour. The way that you get your unit rate is you divide the numerator by the denominator. So 60 divided by 2 is 30. So that would be 30 miles in 1 hour. That is your unit rate. Our other example was 20 miles in 4 minutes. To get to your unit rate, you're going to divide 20 by 4, which is 5. So that would be 5 miles in 1 minute. All right, write the ratio in 3 different ways. Always reduce. There are 45 males and 60 males on the DePauw team. So first we're going to put 45 to 60. That is not reduced. So the greatest common factor of 45 and 60 is 15. So if I divide my numerator by 15, I get 3. And I divide my denominator by 15, I get 4. So I could write that. It says write it in 3 ways, 3 to 4, 3 to 4, and 3 to 4. You need 6 cups of yellow paint and 9 cups of red paint. So our ratio is 6 to 9, but we always want to reduce. So up here, directions, always reduce your ratios to lowest terms. So we're going to divide by 3. So 6 to 9, 6 divided by 3 is 2, and 9 divided by 3 is 3. So that ratio is read 2 to 3. This ratio is also read 2 to 3. And this ratio is read 2 to 3. Okay, so we're going to do some practice with unit rates. So to find the unit rate, you're going to divide the numerator by the denominator. So I'm going to enlarge this just a little bit so I've got some more space to write. So 25 miles in 2 hours. So my original rate is 25 to 2. You're going to show me that you're dividing the numerator by the denominator. So 2 goes into 2 once. That's 0. Drop your 5. And 2 times 2 is 4. You've got 1 left over. So that's 12 and a half. So 25 to 2, the unit rate for that would be 12.5 miles. And of course, that would be a 1 on the bottom, to 1 hour. So if we slide over here to the right-hand side, it says miles in 1 hour. So that would be 12 and a half, 12.5. All right, 561 words in 3 minutes. So our original rate would be 561 to 3. So you're always going to divide the numerator by the denominator. So that would be 187. So that reduces to 187 to 1. So that's your unit rate. So we're going to slide over here. And that would be 187 to 1 minute. Okay, so now I've got $9.20 for 4 pounds of candy. So we're going to divide $9.20 by 4. So that decimal is going to go straight up. 4 times 2 is 8. 4 times 3 is 12, and with a 0 placeholder. So over here, our unit rate would be $2.30. Make sure if it's dollars and cents, you always include your dollar sign. $2.30 for 1 pound of candy. $2 for 3 loaves of bread. So the original rate would be 2 to 3. Now this one's going to look a little funny, but we do divide the numerator by the denominator. So 3 can't go into 2, right? So we're going to have to add a decimal and a 0. So 3 times 6 is 18. Subtract and get 2. Add a 0. 3 times 6 is 18. I think we're going to quickly see this is a repeating decimal. So 0.66666 is going to round up to 67 cents for 1 loaf of bread. So 0.67, 67 cents for 1 loaf of bread. Okay, I'm going to erase this math just so we can write our rule. So question, how do we do these? How do we take the rate and convert it to a unit rate? We always divide the first number by the second number. You always divide the numerator by the denominator to convert to your unit rate. Okay, find the product. Make sure that you label. So 5 hours, if I'm making $8 per hour, oops, I'm sorry. If I'm making $8 in 1 hour, then the question is, how much would I earn in 5 hours? So you would do 1 times 5 on the bottom, so you do 1 times 5 on the top, so you would earn $40 in 5 hours. So answer on that one would be $40. All right, on this one, if I'm going to pay $4.50 for 1 pound of candy, then the question is, how much would I pay for 3 pounds of candy? So we're going to use a common multiplier. If we do 1 times 3 for the denominator, we're going to have to do 1 times 3 for the numerator. So up here, I'm going to show my work of $4.50 times 3. So that would be $13.50 for 3 pounds of candy. So my answer would be $13.50. Okay, so these look a little tricky. We're going to go back to reducing, cross-canceling when we multiplied fractions. This is exactly what we're going to do here. It looks a little weird because we have a fraction in the denominator. So this is called a complex fraction. A complex fraction has at least one fraction in the numerator, denominator, or both. So the first thing I'm going to do over here is I am allowed to put a fraction bar and a 1 on the bottom. So I'm going to try to make that look more like a fraction times a fraction. Now what we're going to focus on is the 3/4 and the 1/4 that are diagonal from each other. So if you guys think about cross-canceling, we divide by the greatest common factor. So the greatest common factor of 1/4 and 3/4 is 1/4. So in the bottom here, if I do 1/4 divided by 1/4, that cancels to 1. And 3/4 divided by 1/4 would cancel to 3. So now all I have left is 17 times 3 going across, and that's 51. So that would be 51 miles. So if you can bike 17 miles in 1/4 of an hour, you can bike 51 miles in 3/4 of an hour. All right, here comes what we always get to, right? The real world application. That's why we're learning how to do all of these tasks here. So a painter can paint 900 square feet in 4 hours. What is the painting rate in square feet per hour? Okay, so let's go ahead and set up our initial rate. So 900 square feet in 4 hours. And I'm trying to figure out how much he's painting in 1 hour. Per hour would be per 1 hour. Oh, so this goes back to what we were doing at the bottom of the first page. Remember all of those? When we did numerator divided by denominator. So we're going to do the same thing here. So I'm going to slide over here and do 900 divided by 4. So that would be 225. If the painter can paint 900 square feet in 4 hours, that means he could also paint 225 square feet in 1 hour. At 1 p.m., you have 20 megabytes of a movie downloaded. By 1:05, you have 55 megabytes. What is the download rate in megabytes per minute? Let's see. At 1 p.m., I had 20, and by 1:05, I had 55. So the first thing I'm thinking about is the time. Well, if I started at 1 o'clock, and I ended at 1:05, that means that I was downloading for 5 minutes. So that's the first thing I'm thinking mentally in my head. The next thing I'm thinking is, what's the difference between 55 and 20? So how many megabytes downloaded in that amount of time? So 55 minus 20, that's 35 megabytes downloaded in 5 minutes. At 1 p.m., you have 20 megabytes of a movie downloaded. By 1:05, you have 55 megabytes. What is the download rate in megabytes per minute? Okay, so they're asking for the unit rate again. So I know over here on the right it has to be 1 minute on the bottom. What I do know is that in 5 minutes, there were 35 megabytes downloaded. So 35 divided by 5 would be 7 megabytes per minute. Okay, so we're going to move on to day 2 notes. You guys can either take a break for a minute if you want to push pause. This is kind of a lot of note taking, or you can just move on. These notes are a little bit quicker than the first set, so we should be done in about 10 minutes. Okay, ratios and rates. Notes day 2, word problems. Graph the speed of a subway car. Use time in minutes for the x-axis and distance in miles for the y-axis. Label your graph with 3 labels. So whenever we're graphing, we always have to give our graph a title. So it says, graph the speed of a subway car. So I am going to title this Subway Car Speed. Now, also in the directions, it says use time in minutes for the x-axis. So the x-axis is right here. It's our horizontal axis. And it says time in minutes. So usually the way that you're going to see this on a graph, you'll see time. And then in parentheses, you'll see what unit they're using in time. Minutes, hours, seconds, days, weeks, etc. And then it also said to label your y-axis distance in miles. So we're going to do something similar. I'm going to put distance. And then in parentheses, that could be feet, yards, inches, but this says miles. So MI is the abbreviation for miles. Okay, so we are ready to graph our points. So if we look at our x coordinate, that's 1/2. And our y-axis is the vertical axis, and that coordinate is 1/4. All right, so I'm going to enlarge this a little bit. So I'm trying to find 1/2 on the x-axis. So 1/2 is going to be halfway between 0 and 1. So 1/2 is going to be about right here. Now my y-coordinate was 1/4. So 1/4 is going to be way down here at the bottom. So where those 2 points meet is going to be about the first point on my graph. Okay, if we look at the second set of coordinates, I have 3 on the x. Well, that's easy to find. Okay, so here's 3 on the x. So I'm going to go straight up from that. So there would be 3. And my y coordinate is 1.5. Okay, so 3 on the x, 1.5 on the y. So I'm going to go up from 3, over from 1.5. So that second point would be right here. So now what I'm going to do is connect those 2 points with a line so I can see the progression of the speed of the subway car. Question, interpret the graph. What does the first point represent? So the first point is this one way down here at 1/2 and 1/4. So the first point represents the subway car went 1/4 of a mile in 1/2 of a minute. Now it says find the speed of the subway car. So how fast is that car traveling? If it went 1/4 of a mile in 1/2 a minute, how far can it go in a whole minute? So I'm going to go ahead and set up my ratio. 1/4 of a mile in 1/2 a minute would be how fast per minute? So to get from 1/2 to 1, we would multiply by 2. So 1/4 times 2 is 1/2. So the subway car is traveling 1/2 a mile per minute. That would be the rate of your subway car. Okay, use a ratio table to solve. We have a lot of information going on in this problem, so stay with me. You mix 1/2 cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use? Use a ratio table to find an equivalent ratio in which the total amount of yellow paint and blue paint is 15 cups. Okay, so let's take a look at our table here. So I've got blue paint in the middle, I've got yellow paint on the left, and we've got our total cups. So the final question was, use the ratio table to find an equivalent ratio in which the total amount is 15 cups. Okay, so the first thing I'm going to do, so this is 5 cups total over here. How would I get to 5? Let's see, if I doubled the amount of paint, if I did 1/2 times 2, that would be 1 cup of yellow. And if I did 3/4 times 2, that would be 1.5. Now, was 1 plus 1.5 equal to 5 cups? No. Okay, so some of this is going to be trial and error. What if I, instead of times 2, what if I do times 4? Okay, so that would be 4 halves, which would be 2 cups of yellow. And if I multiply my 3/4 times 4, that would be 12/4. 12 divided by 4 is 3. Is 2 plus 3 equal to 5 cups? Yes. 2 plus 3 is 5. Okay. Now, I'm trying to get up to 15. Well, I know that 5 times 3 is 15. To get from 5 to 15, I would do times 3. So I also must need 3 times the amount of yellow paint and 3 times the amount of blue paint. So 2 cups times 3 would be 6 cups of yellow paint, and 3 cups of blue times 3 would be 9 cups of blue paint, and 6 plus 9 is 15. So your ratio would be 6 yellow to 9 blue. How much yellow paint and blue paint do you use to make 20 cups of green paint? 20 cups. So I'm going to go back up to a factor of 20. I know that 5 is a factor of 20. So to get from 5 to 20, I'm going to put 20 down here, and I'm going to make myself one more row in my table. I think that would make the most sense in my brain. Okay, so I'm going to go back up to how much paint we used for 5 cups. We had, oops, sorry about that. We had 2 cups of yellow and 3 cups of blue paint to make 5 cups of green paint. Now, I know to get from 5 to 20, we would have to quadruple. We'd have to multiply that amount of paint by 4. So I'm going to take my 2 cups of yellow, and I'm going to multiply 2 times 4. That's 8 cups. And I'm going to take my 3 cups of blue paint and multiply that times 4, and that would get me to 12 cups of blue paint. Now you have to look across the entire row. Is 8 cups of yellow paint plus 12 cups of blue paint equal to 20 cups of green paint? Yes, 8 plus 12 equals 20. All right, we are finished. That was a lot of note taking. If you guys have any questions or need help, make sure that you email. Have a good day.